and my partner for this project is Matthew Stringer. So for our 176 project, we decided to implement an image Inpainting for irregular holes using partial convolutions. This paper, I think, was super interesting and a lot of fun. Basically, the quick rundown: we're feeding in images that have like splotches or creases, and then regenerating an image by filling those splotches and improving, hopefully getting to what the original image looks like. So yeah, I think the application of this project is very human. Like, you're able to, maybe let's say you have like for me it was personal because I went back to China. I was looking at old photo albums and pictures of my grandparents when they were young, and some of them have creases, and like I think it'd be a good gift to be able to fill in those creases and recreate those original images. It's a very human aspect. You can help people basically augment like their old family photos and of their loved ones and stuff like that. So yeah, going on to how we implemented it. So we used places 2 as a data set, and in order to save on compute time and all that, we resized the images to 256 by 256. So these are what the photos look like. They're consistent. There are places and some people too. Then we create using generate masks. We're using like basically doing random splotches, generate random splotches that get multiplied with the original image to create our train X, our data set, and then that when we feed that in the train Y, the actual output or expected output that it's taking the loss function on would be the original image. So this is what the splotches would look like. You have the white space in the back because when you multiply, that's what areas you want to keep, and then the black spaces go to 0, so you will get an image with your original image with like black splotches over it, and that's the areas we're going to fill. So yeah, let's go on to how our actual algorithm works. So we have a partial convolution 2D that's just the implementation that we have for our forward. We used PyTorch to create the backward, and then we have partial convolution UNet. So here's a quick explanation of, I think this image is pretty good. So you're essentially like on the downsampling route, you are shrinking down the image with your kernel by taking, gaining those feature space, increasing that feature space, that data that you're kind of drawing the patterns from for images, with that blurry, with splotches. And then as you rebuild the image, this is the bottleneck. And then as you're rebuilding the image, you're feeding in those that models the weights. That'll basically tell you what features you expect for that type of, like, on the basically gives them the context, right? You have splotches, let's say in the background, like a blue sky or something. Then you have a hole there. Then it'll say like, okay, you have a blue sky in the background. The splotch probably is more blue sky. And then it's a little more complicated with faces, but when you train on more faces, it can figure out, oh, okay, a nose is supposed to be there, an eye is supposed to be there, stuff like that. So it gets the name partial convu UNet because it's creating a U shape on the way it's downsampling then upsampling. So yeah, here's our implementation. So then next we have the data load I already explained. It's just basically running the processing the images to make them 256 and loading them in as vectors. And then for the inpainting part, where is it? Let me do a live demo of the live inpainting. I think this will be pretty fun. So I'm gonna turn off my video so that I can activate the webcam. All right, so hope you guys can still hear me, but yeah. The way we trained our data set, I actually have it running in the background just so you can see. Terminal 1. Yeah, so we have it so that it's running on, the way in our train, we can basically change our training parameters, like whether we want 32, 16, 8 batch size. That will affect how many images are being processed at once. The higher batch size, the faster it is, but it can't capture as many features. Number of epochs is how many times you're going through the data set. Right now it's set to 5, but during the actual thing, we kind of set it to 50 and having an automatic stop when the amount of the loss function isn't reducing by a certain rate anymore. So we kind of set that arbitrarily, but it worked out pretty well. It stopped around 25 epochs. Then our learning rate was kind of a big big parameter that we cared about, because we originally were testing with pretty high learning rate of like e to the negative 2, and we're getting pretty not great results, and we decreased that by a magnitude and another magnitude, and we got to e to the negative 4, and we're pretty happy with it. Because if you go higher, then sometimes you'll get stuck and it won't reach the proper optimums and stuff. So yeah, we have a little test bar that tells you how far it's going into the epoch. Definitely took many hours to train each time. We would kind of have the computer running overnight and stuff like that. But basically we have it save after every epoch into our checkpoints, and that kind of helped us not lose any data. And we had to delete some of them just because of this for saving space. But here are some of them that we picked out, and then you can kind of sample. Like, I'll do a live demo of it right now, but you can sample some of them. You can just test out the different ones by changing the model path. So let's try this one first. So when I run it, webcam will pop up. Unfortunately, I don't know why it's inverted right now. It's inverted, but you can easily change that. I press C to capture an image, and then it will process, create a generate mask, add the mask, and then send it through our model. So like here you can see, it's putting this mask on this original image and filling in those spaces. We have some artifacts like this repeating square thing. That's kind of, I think, issue with maybe that we're not really sure about, but I can keep showing demos, with like water bottles of like maybe a blue color with like a cow in it or something like that. See, it does a pretty good job. The resolution, I think, is a bit messed up, but you can clearly see that the mask areas line up here, and it's doing its best to fill in those areas. So it's generating those images and subtracting it from the original image, so that you're kind of just getting the generative splotches, because you don't want to recreate the whole image just for fun. Like you have the original image, you might as well take advantage of that. So you're basically adding the image with the splotches, adding on the generated splotches, so then you have like a full image instead of recreate the whole image. Yeah, that was an explanation of our project. I hope you enjoyed. Thank you.